All right, so welcome back to yet another lab activity. Okay, so this lab activity that we're working on today is lab 7.4.2. And hopefully by now you've had a chance to take a look at my little subnetting video that I made. And if you haven't, then that's okay. We're gonna get into this anyway. And what I'm looking for is my NetLab. Here it goes. Okay, so NetLab. I'm going to go ahead and schedule a lab for myself. And this just happens to be Net 126. All right, and we're going to go down through here and we're going to find lab 7.4.2. Here it is. All right, and I don't know, I like using these pods that are out here. We'll just schedule pod 12 and we'll schedule for immediately. And I'm going to schedule this lab for a little bit longer. 3 hours. Okay, if I can't get it done in 3 hours, then I'm going home. All right, so it says here we're good to go to enter the lab. So let's do it. All right, so lab 7.4.2. What are we going to be doing? Well, let's take a look. We're going to implement DHCP over IPv4. All right, so we need to do some stuff. Now, it just so happens that in advance, I went ahead and downloaded this file, and I have it on a Word document, so we won't really need this. And so let's go take a look at R1. Okay, R1, R2, S1, S2 are still in the process of booting up. So I'm just going to pause my video for a minute. Okay, so while we're waiting for those things to boot up, let's take a look at our lab. And I've got it open in Microsoft Word so that we can type into it. Now, you'll notice that we're given the interface addresses for G00 on router 1 and G000 for router 2, and those are going to use IP addresses of 10.0.0.1 and .2. These are just going to be links from router 1 to router 2. Okay, so for that, anytime you're connecting two routers together and you're not going to have anything else, that's the only thing that's going to be on that network, all you need is two addresses, in this case, .1 and .2. Okay, so we can have our subnet mask that looks like this, 255.255.255.252. And this is going to be pretty standard for router-to-router configurations, because with this 252 subnet mask, and you can pencil it out on a piece of paper if you want to, that's going to be .1111. It's going to be 6 ones and 2 zeros, which is going to give you two usable addresses on that particular subnet, but that's all you need. And this is just by way of conserving address space. Okay, now let's go down through here. Now, first things first, it says figure out what you're going to need as far as networks and subnets. Okay, so in my previous video, I did this on the board, and we figured out that for subnet A, we could use 192.168.1.0 and use a subnet mask of 255.255.255.192. Okay, and that's going to give us 62 hosts total. And then we kind of figured the same thing for subnet B. If we do a .64 network and use .224 for our subnet mask, then that'll give us 30 hosts. And then on subnet C, we don't need but 12 hosts, and we could use the .96 network with a .240 for our subnet mask, and that's going to give us 14 usable hosts, which is going to be just fine for what we need. So now we know our subnet addressing, and so now we're ready to proceed. And if you want to, you can go back up here to the table and you can fill this out, with the different addresses that you're going to use. Now for PCA and PCB, you'll notice those are just say DHCP, and the reason for that is because this lab is about establishing DHCP on a Cisco router. And all Cisco routers have got DHCP capability built in, so you don't have to have a separate DHCP server. Now then, okay, cable the network as shown in the topology. In a face-to-face class, you would have to do this. You would have to actually cable up your devices before you could start doing any of this work. And up there in the chart, it tells you specifically which ports to use for different device connections. All right, so let's go ahead and get started. By now, our router Okay, so finally we're rebooted. Okay, so now we're ready to start entering some commands. Now in the lab activity, all right, all it tells us here is what to do. It doesn't tell us exactly how to do it. Now hopefully you've been keeping a notebook of commands. These basic router settings are going to be the same for pretty much every kind of lab that you're going to do throughout your time in school. And so it's a good idea to go ahead and have these commands listed out in either like a Word document or have them written down in a notebook, because you know you're going to use them over and over again. Okay, configure inter-VLAN routing on R1. So we're going to need to bring up, okay, so we're going to be using G001 for our interface, and we're going to be programming sub-interfaces. These things are interesting. You can have a ton of sub-interfaces on each physical port. So you can have like 6 or 8 networks, sub-networks running on one line. Okay, so how are we going to do this? Step 4. Okay, first things first, interface G001.100, encapsulation.1Q100, description is going to be client VLAN, and give it an IP address. This is going to be the first available IP address in the first network. And don't forget to give it this new subnet mask that we figured out. Okay, then we're going to go to interface G001.200, encapsulation.1Q with an identifier of 200, and then description is management VLAN, because that's what it says in the directions. And then the IP address for this interface, this is going to use the first available address in the .64 network. What did we say, 224. Okay, this is, again, is from our computations earlier. Okay, and then we got one more. Interface G0/0/1.1000. Okay, this is going to be our native VLAN. .1Q1000 and a description. The native VLAN, and it doesn't need an IP address. And now we're going to end. Okay, show IP interface brief. Okay, very good. So we haven't done anything with gigabit 000. Gigabit 001, see, it says it's unassigned, but that's okay because we've got our networks defined here on the sub interfaces. So that should work just fine for us. And if it doesn't, we'll come back and fix it. Okay, now we're supposed to also configure G00. Okay, so interface, wait a minute. G0/0/0. Now this guy needs an IP address that we got from the table up above. (10.0.0.1) with a subnet mask of 255.252. Okay, no shot. All right, now interface G0/0/1. Hang on, let me check my directions and make sure I'm not doing this wrong. Okay. I don't need that. Okay, so that is up. All right, now I need to go over to R2. Oh, wait a minute. Before I do that, I'm going to enable IP routing. Well, IP routing is already enabled. I'm going to give a default route. 0, this is called wildcarding. So basically, if any traffic hits this router that it doesn't know what to do with, regardless of the address and subnet mask, it's going to throw it over to the other router and see if it knows what to do with it. Okay, so this is called a default or a gateway of last resort. So we only have one other router on this network, and so we're going to name that router our gateway of last resort. Okay, so we've got that done. Now let's go to R2. Okay, and we have the passwords Cisco and class. And we type those in, and now we're good to go. Okay, now R2 needs a way to communicate with R1. So well, first things first, let's do this. Okay, see here, we've got these different interfaces, but none of them have been set up yet. Okay, so the first thing we're going to do, config T. Now let's take a look at interface G00. Okay, now this is the interface that's going to connect to the other router. So we're just going to give it an IP address of 10.0.0.2. And these subnet masks have to match exactly, or else it won't work. No shot. Okay, now we're going to take a look at interface G0/0/1, which connects to some other destination. And it's going to have, okay, this is going to be our third network. 192.168.1. This is the 96 network, so we're going to use an address of 97. .240. Okay. No shut. And just like we did on the other side, we're going to establish a gateway of last resort, and in this case it's going to look like this. IP route 0.0.0.0. Okay, any address, 0.0.0.0, any subnet mask, we're going to send it to 10.0.0.1. So basically, if something hits the router and it doesn't know what to do with it, it'll pass it over to 10.0.0.1 to see if that router knows what to do with it. And if both routers come up empty, then you'll get a message back saying something like destination host unreachable. Okay, now we're supposed to verify. So let's ping 10.0.0.1. Okay, so our router interface is up. Now let's try pinging those sub interfaces that we made. 192.168.1.1. Okay, that worked. And what was the other one? 1.65. Okay, good deal. Okay, so all of our interfaces have IP addresses, and they're all talking to each other, so yay us. All right, now let's go back to our instructions and see what we're supposed to do next. See right here where it says static routing for both routers? That was that IP stuff that we just did, the wildcarding. Okay, now we need to program our switches. Okay, so we're supposed to disable DNS lookup, Cisco class, plain text passwords, encryption, banner, running config, startup config, set the clock. Okay. All right, good deal. Well, let's get started. Let's go ahead and start with switch number 1. Config terminal. Okay, this is S1, so hostname S1, no IP domain lookup. The reason we type that command in is so that in case we accidentally type, like say you were to just type some random characters and then hit the enter key, if domain lookup is enabled, then this thing will go and try to resolve this to some valid command, and it takes it like 5 minutes to figure out that it's not a real command. So, it's just a time saver. So if I just type junk and hit return, see it just says invalid input detected, and I'm right back to work. Okay, enable secret class, line con 0. Password. Password Cisco. Login, exit. Line BTY 0. Shoot. Well, we'll just do this. Service password encrypt. Clock set. Oh, okay. And it is now 10:50. Man, time flies when you're having fun. Okay, clock set. Copy, run, start. All right, now we're going to go do the same thing for S2. Saved our configurations. All right, what's next on our list? All right, well, this is going to be fun. Create VLANs on S1. Create name as specified, configure and activate management. Use a second IP address. Okay, let's do this thing. And we can start with S1 or S2. Let's start with S1. All right. Okay, so we got a VLAN 100, and the name of this one is clients. Name management. Okay, VLAN 999. Name. Okay, this VLAN 999, we're not going to really use it for anything except for all the ports that we're not using. Oh, oops. Okay, all the ports that we're not using, we're going to assign to this VLAN so that they basically just go off into La La Land. VLAN 1000, name native. Okay, now interface. Now VLAN 200 is going to be our management interface. Okay, so what we're going to do is we're going to give it an IP address of 192.168.1. We use 65 for the router. We're going to use 66 for this guy. 255.255.255.224. Okay. And then IP default gateway. Is going to be our router. Okay. Good deal. Oh. Oh, it's not shut down. Never mind. Okay, now port assignments on S1. We're supposed to do this. Okay, interface F0/6. Switch port mode access. VLAN 100. Now we're going to use the interface range command so that we don't have to type this in for every single fast Ethernet interface because there's 24 of them. 1 through 4. F0/7 through 24. Okay. Switch port mode access. Okay, so these switch ports are, they're not going to be active anyways, but if they ever did become active, they would be members of VLAN 999, which is not going to let anybody do anything. This is part of your security. Okay, now I'm going to shut those down. Okay, now interface. Okay, so for interface F05, this is going to be a trunk line, which means it's going to be able to accommodate multiple VLANs. Okay, so switch port mode trunk. We're going to make it part of the native VLAN 1000. We're also going to allow okay, hang on a second. I got to pause. All right, sorry, I had to get up and answer the door. All right, where were we? Switch port trunk allowed. VLAN 100, 200, 1000. Okay, so now we've got a trunk line going from S1 to R1. Okay, so hopefully that's going to do what we need it to do. All right, now what is the next thing we need to do? Let's go take a look. VLAN 200. Okay, so we used port 5 to connect to our router, I believe. Okay, so yeah, port 5 connects to our router. Port 6 connects to our PC. This is on S1 we're talking about. And then on S2, we got port 5 connecting to our router, same as S1. And then for PCB is connected to port 18. Okay, fantastic. Just wanted to double check and make sure that I didn't have these port assignments messed up, but it looks like we're okay. All right, now we got to configure VLAN. That was on S1. S1. All right, well, let's keep on moving. Next thing we need to do is configure some DHCP servers on R1. We need 2 DHCP servers running. Sounds challenging, but I feel like we can do it. Okay, R1. Okay, cool. All right, now then, config T. Okay, now we need to make some DHCPs. So let's do this. IP DHCP. Before we do anything, we're going to go ahead and establish our excluded addresses. (192), and this is going to be a range. Okay, so we don't want to see DHCP is going to hand out addresses, but we don't want it to hand out the addresses of our routers and switches. So we're going to exclude the first 5 addresses. 1, 2, 3, 4, 5. Okay, 192. And yes, I was counting on my fingers. Okay. Now we're going to also do this. (192.168.1.65). Wait. All right, hang on a second. I got to go back and consult my instructions. Okay, looking at our instructions just to make sure I don't mess anything up. Okay, subnet A is going to be the client VLAN at R1. Okay, so this is going to be DHCP assigned. So yeah, we're good to go with that one. Now, subnet B is our management VLAN. It does not have any DHCP on it, so we don't have to worry about that. Subnet C is another client network. This is the one with only 12 hosts, and it starts at 97 and has a mask of 240. Okay, so with that knowledge in mind, let's go back over to our configuration. Okay, 97 we want to include, and it says we're supposed to leave out the first 5 addresses. So 97, 98, 99, 100, 101. Okay, that should do it. Sometimes it's good to go back and look at your instructions just to make sure that you haven't gone crazy between the last time you read them and now. Okay, now we need to establish a couple of DHCP pools, one for subnet A and one for subnet C. So let's do this. IP DHCP pool R1 underscore, and you can't have any spaces in here. It can be mixed upper and lowercase. Okay, so DHCP pool R1 client LAN. Okay, now let's give it some parameters. The network it's going to be operating on is going to be 192.168.1.0 with a subnet mask of 255.192. Okay, that was the first network we came up with. Okay, the default router for this network is 192.168.1.1. Okay, and the domain name they want us to use is going to be ccnalab.com, and you'll use this over and over again. Okay, now we're supposed to give it some leasing parameters. Go back down my instructions. DHCP. Okay, configure the lease time for 2 days, 12 hours, and 30 minutes. They would have to throw this in there. Okay, so lease. 2 days, 12 hours, 30 minutes. Okay, now we got to establish another DHCP pool. Okay, IP DHCP pool. This is going to be the R2 clients. Y'all are probably laughing at my slow typing. Okay, the network for this one is going to be the network C, which was 192.168.1.96. That's the network. .240. Okay. The router for this one is 192.168.1.97. That's the first address that we used. Domain name is going to be ccnalab.com. And I think the leasing for this is the same as the other one. Okay, all right, yep, says use the same times as before. So this is going to be lease 2, 12, 30. Okay, now end. You definitely want to do a copy run start here, because if anything happens, you'll lose all this work. Show IP DHCP pool. Okay. All right, so here's our address range. We've got 5 excluded addresses. Current index is .7 because apparently somebody's already obtained an address from this. Okay, let's see. Okay, R2. Now we have to do something else. Let's see. So I think we've done everything we were supposed to on R1. Now we got to set R2 so that it's a DHCP relay helper. Okay, for address. All right, let's do it. So let's go to R2. Because, okay, by default, routers don't pass along DHCP requests. They only service the LANs that they're directly connected to. But in this case, we've got one LAN connected to R1 via a switch, and then we've got another network that's connected to R2. It doesn't have a direct connection to R1. Okay. All right, so on R2, what do we need to do? Interface G0/0/1. Oh, this will help. All right, so we're looking at the G001 is the interface that faces the LAN that we're connected to. So we're going to give it an IP of 10.0.0.1. Okay, so this means that once we initiate this command, then any DHCP requests that come into this interface will get passed along to router 10.0.0.1, aka R1. Okay. Okay. All right, so we've got our DHCP server running. So far it hasn't forwarded any requests, but I think that we are done here. So here's what we're going to do. We're going to go to PCA, and we're going to go to our command prompt. ipconfig. Okay, so PCA has already obtained an address from the DHCP server, 192.168.1.6. And it's got the correct subnet mask. Okay, now let's take a look at PCB. ipconfig. Okay, so this guy's got an IP address of 192.168.1.102, which is good because we excluded up through .101. Default gateway is correct. Okay, so this is what you're going to screenshot. Take out your snipping tool and screenshot this, showing that it's got the correct domain and it's got the correct address and all this good stuff. Got the correct default gateway. And then we'll do the same thing for PC. Okay, PCA, it doesn't have all its information. So let's do this. Okay, that's looking much better. What we did was we did an ipconfig/release and an ipconfig/renew. And when you do that, that sends out a DHCP request for any available DHCP server to give me an address and a subnet mask and a next hop router. Sometimes you can also configure DHCP to supply DNS addressing, which we did not do for this particular lab. So if you screenshot this and then also screenshot this, then that's all you have to do, because then I know that you did everything else correctly. Okay, so golly, this has gone on a long time. I'm going to try to trim this down some, but that basically is a walkthrough for Lab 7.4.2.